Hello guys, welcome. In this video lecture we are going to see about matrix decomposition. Specifically we are going to see about the mathematical intuitions of lower and upper decomposition of matrix. So we need to understand before getting into the low LU decomposition, we must understand, right, why we need to decompose the data, or why we need to split the data, why we need to simplify the data, simplify the matrix, right? The reason behind is, the first reason is you are trying to solve the equation. You are trying to solve the equation, right? Which means that we want to find the value of x1, x, y and z. Fine. Secondly, we need to optimize the computation. Optimizing the computation means, say for example you have an n-dimensional matrix. You need to calculate for each and every element. Let's assume if you have a method where you can make some entries 0 or you can make some entries eliminated, then it's going to obviously reduce the computation. The complexity of the computation can be reduced. So for that purpose we can use this matrix decomposition. And finally, to analyze the data. Analyze the data in the sense which coefficient is highly significant, or which leads to a lower dimension of data. So for those reasons, to analyze those data, we can use this matrix decomposition. Okay, fine. So this agenda of our video is going to be, we need to understand the definition of this LU decomposition and why do we actually need to use it, especially in data science and artificial intelligence. Why do we need to use it? That we will be understanding in this video. And how does it compare to Gaussian elimination? Okay, so you must understand what is Gaussian elimination. This is actually Gaussian elimination is actually a simplified version of LU decomposition. Okay, so we will get into that. We'll just get into the definition of what is Gaussian elimination in the mid part of this video, and what are the 5 steps involved in this LU decomposition, right? And that's it. And then we will have a real example. We'll take an example and see how it works. Okay, we'll just do the math of the matrix and derive at this LU, and basically we are trying to solve the equations. And finally we will summarize what we have learned so far and where it is applied in data science and artificial intelligence. Fine. Okay, now what is LU decomposition? We have seen that matrix decomposition is used for solving the equation, optimization, the computation, and analyzing the data. So what is decomposition, LU decomposition in specific? What we are doing here is, we are basically splitting the matrix into 2 triangular matrix. The one is lower triangular matrix with values below the diagonal. So values above the diagonals will be 0, right? Then we have another matrix which is called as a upper triangular matrix, where we have values above the diagonal. Okay, basically the inverse of lower. What this helps us, why we need to split into lower and upper triangular matrices? We are trying to solve the equation. That's a basic intention behind splitting this. Okay, so how it actually looks is what is given in this image. See, the matrix is being, this is the diagonal, and you have here L21, L31 and L32, and all the above values above the diagonal is 0. Okay, now when you examine this U upper matrix, upper decomposition, this is a upper triangle matrix, which means you have the values here above the diagonal. Here you have values. But see, when you take this one, I'll just take another color. When you take this one, these are all 0, but here you have values. So that's the basic difference between this. Okay, fine. Now, as I said we want to find what? We want to find the x value, y value, z value by splitting a matrix into upper diagonal and lower diagonal, and we are trying to solve it. So for this, before we could go into the example, I want you to understand 5 steps what are involved in this process. The first step is we are going to initialize. What we are going to do? We are going to you don't worry, I'll when you get into the example you will understand, but we need to understand what are the 5 steps basically, because what we are going to arrive at, that you should have an idea, right? So I'll just walk you through the 5 steps involved, but even if you don't understand, I'm getting there with an example, you will be able to understand very clearly. Okay, so we are going to initialize u and v, and later this u and l, not u and v, it's u and l. So later this u and l will be updated. Basically we are going to initialize in the first steps. I'll tell you how we are going to initialize when we get into the example. Second step, what you are going to do is, here you have seen, right? Here you have seen L21, L31 and L32. We are basically interested in finding this. So what you call this is multipliers. Okay, in step 2 what we are doing is we are finding the values of L21 and L31, and then we are, in the first step we have initialized the L, right? L and U. So what we will do is we will update the value of L and U based on this value which you get here. Okay, fine. Now third step is also about updation only. Third steps you are going to update the L value, that is you are basically going to find this value L3, L32. Okay, that value you will find. With respect to that L32, you are going to what? Update the row 3. That will be done in step 3. Okay, fine. It may sound vague, I'll get into the example, you will be clarified. Okay, no worries. Then in step 4, once we have updated the L value and U value, what we have to do is, the next step is the substitution. For that substitution we have 2 steps. One is forward substitution in step 4, which we will be doing, and finally in step 5 what we will do is backward substitution. What we will do? Backward substitution. When you do that, you will get what? X value, y value and z value. Okay, so now let's get into the example, and then only you will be able to understand. For that I am basically taking a equation. So that equation is x plus y plus z. I have written here, but let's do it manually. Another equation I have is 2x plus 3y plus 7z. And the third one is 3x plus 4y plus 10z. Okay, let me check if they have given the right value. Give me a second please. Yes, okay. And then we have the equation to be 6, then here you have 20, and then you have here 28. Okay, fine. Now what was our step 1? Can we go into the step 1? We want to initialize, right? We want to what? Initialize. Okay, so I am basically converting this to an matrix format. So I have here 1, let's take it as A, equal to 1, 1 and 1, because x, y, z coefficient is 1. For the second equation, what you have, this is my first equation, this is second, and this is third. Okay, so for the second equation I have 2. I believe in writing it manually, only then you will be able to understand, than telling you taking those example and reading out those numbers. I believe as I do, you will be able to understand very clear. Okay, so that's how teaching works, I believe so. So this third equation is going to be 3, 4. You will have some time to work out things in your mind. Okay, when you go like this, it's a bit slow and you will understand it very clear. That's what I mean to say. Okay, so what we are going to we'll just have this as b. So b is going to be 6, 20, 28, which will be later using it for forward and backward substitution. When you come to the forward substitution, at that time only we'll be using this value. So let's keep this b aside. Okay, now first step is what? First step is what, guys? Initializing, right? Okay, fine. First step is initialization. Let me write it here. So my u value, upper triangular value, is going to be what? The same thing, 1, 1, 1, 2, 3, 7, 3, 4, 10. Okay, now my lower triangle value is going to be what? 1, 1, 1. Okay, here I have 0 and here 0. Now here I am going to calculate L31, L21, L31, L32. But we will do in 2 steps. The first step we will calculate what? So this L1, I'll take another color. Okay, this L1, L31, L32, all these are what? Called multipliers. All called what? All called multipliers. Now in step 2, we need to find the multipliers, right? This one, this one. This we will do it in 2 steps. Step 2 we will be doing L31 and L21 and L31, and in step 3 we will be doing the L32. Okay, so to calculate L21, what we need to do is, of this U matrix, we take this one and we are going to divide by this one. So we get 2 by 1, that is equal to 2, right? Then again for L31, what you are going to do is, we are going to pick this divided by this. So that's going to be 3 by 1, that's equal to 3. Now the lower decomposition matrix is replaced with 1, 0, 0, and here it is replaced with 2, 2, and here it is replaced by 3, and here it's 1 because it's diagonal, and again it's 1 here, here it's 0, and L32 we have not yet found. So this is the updated matrix of L. Now we have to update this U matrix with respect to this multipliers. So the changes which will be is row 2 and row 3. So row 2 will be row 2 minus what? 2 into R1. Okay, and R3 will be, so doing that what we get is R2 is what? R2 is this one, and our R3 is what? R3 is this one. Okay, 2, 3, 7 and 3, 4, 10. 2, 3, 7 minus 2 into R1 is 1, 1, 1, as you can see here, 1, 1, 1, 1, 1. Okay, fine. So what you get here is 2 into 2 minus 2 is 0, 3 minus 2 is 1, 7 minus 2 is 5. I hope you are getting it. What we have done here, let me simplify it again. 2, 3, 7, right, and this is 2 into 2 into 2. So basically we are minusing this by this, again this by this, and this and this we are minusing. 7 from R1, that is 2. So 2 from R1, and again 3 from R1. It goes like that. So we are ending up with 0, 1 and 5. Okay. Now what we have to do? We have to find R3, right? We have just found R2. We have to find what? R3. So R3 is what? R3 is 3, 4, 10. So we are having 3, 4, 10, and again we are multiplying with 3 times. This time 3 into R1. R1 is always 1, 1, 1 here. So it is going to be 3, 4, 10 minus 3, 3, 3, which gives you 0. 4 minus 3, 4 minus 3 is 1, and 10 minus 3 is 7. So what we end up? 0, 1, 7. So this is our updated R2. This is our updated R3. Where we have to update? In U1. So U1 will become what? We have 1, 1, 1, and then R2 is 0, 1, 5, and then R3 is what? 0, 1, 7. Right? So this is step 2. Now we have to go for step 3, where we have to find the multiplier of what? L32, right? Okay. So step 3 is what? Finding the multiplier of lower decomposition matrix, right? So that is L32. See, this value we are basically going to find. Okay. So here this L32 is 1 here, divided by 1 is equal to L32 will be 1 here. So our lower dimension matrix now becomes what? 1, 1. This diagonal matrix, I am just putting it to make things easy, and here we have 2, 3, and here we have 1. Fine. This is what? This is what? Updated multipliers. Updated what? Updated multipliers. Right? Okay. So now this time what we have to do? We have to update. We have to update what? Step 3 is updating R3, okay, of upper decomposition matrix, that is U. So what we get here is R3 is equal to R3 minus how many times? Multiplier is what? 1 time. 1 into what? R2. Okay. So what we have here? R2. This is what? This time this is R2 and this is R3, right? So R3 is 0, 1, 5 minus 1 into what? R2 is 0, 1, I'm sorry, here this is 7, R3 is 7, sorry, here it is 0, 1, 5. So the updated R3 will be what? 0 minus 0, 0, 1 minus 1, 0 again, and 7 minus 5, 7 minus 5 is what? 2. So what we have? R3 is this. So now we are going to write it here. We are going to what? We are going to write it in the updated matrix of U. So U basically becomes now 1, 1, 1 and R2 was 0, 1, 7, right? Let me check. 0, 1, 5. R3 only has changed. Okay. New R3 is what? 0, 0, 2. 0, 0, 2. Now listen guys. Has this matrix been formulated to what? It's been formulated to upper triangular matrix, right? It has been formulated to upper triangular matrix. Now the updated L is what? Let me write it here itself. Updated L is what? 1, 1, 1, 0, 0, 0, here 2, 3 and 1, right? Now our step 4 is step 4 is step 4 is what? Forward substitution. Okay. So in forward substitution, what we are going to do is we are going to find the value of okay. Step 4 is what? Forward substitution. How we are going to do this forward substitution? We are going to basically do this. So what we get here? Y 3, I'm sorry, B value you should know first. It is 6, 20 and 28. Okay. So y1 you just have here y1, these coefficients are 0, so this is going to be 6. Now again y2 y1 2y1 plus y2, this is 0, y3 is 0, so that is equal to 20. So you end up here with, you substitute y1 as 6, this becomes 12, and y2 becomes what? y2 becomes here 8. So this is 20, this is 8. Now next we have is next we have is this equation. So we get here 3y1 plus y2, right? Coefficient is 1 for y2 and y3. So y3 is equal to 28. So you get here 18 plus 8 plus y3, that is equal to 28. And so y3 will end up in what? 28 divided by 28 minus 26, that is equal to 2, right? Okay, fine. So we have 6, 8, 2. So what we have to do here, next step is step 5. Step 5 is what? Backward substitution. Step 5 is what, guys? Backward substitution. Okay, for that we need to solve this in the form of this. Okay, so what is the new b this time here? 8, 6, 8 and 2, right? So what we are going to do here, we are going to take the upper matrix. Upper matrix is what? 1 1 1 0 1 5 0 0 2. Let's write it here. 1 1 1 0 1 5 0 0 0 2. Yes, 0 0 2. Okay, so again this is in the form of upper triangular matrix. The coefficients of x and y are 0, so we have only what? Coefficient of z. So 2 into the coefficient of z is equal to what? Is equal to 2. This is z, right? So 2. So z value is going to be 1. Now we know the z value. Now consider this one. We are going in a backward way, right? From z we are going. So x is what? X is 0. So we have here y plus 5z, which is equal to 8. So y value is what? 3. Y value is what? 3. Z value is 1. Now let's consider we are going backwards and taking the values for x. This is y, this is not just x. Okay, so this time it's going to be x plus y plus z is equal to what? 6, right? 6. Okay, now we know that x and y value is 3 and z value is 1. So we know x is equal to 6 minus 4, so added up to 4, so this becomes 2. This becomes what? 2. So x value is 2, y value is 3 and 1. Okay, so what we have done, we have ended and found the solutions to be this: x, y and z. Okay, so this is how you do this LU decomposition. But as far as data science